Hello, my name is Ujjwal Shrestha.
And I'm Pat Moore.
In this presentation, we would like to share how we ran our experiment, how we brought quality into it, and what are lessons learned that could help other similar projects in future. Starting with the situation of this project, we are going to use a siphon that will draw down our water from higher level to lower level using a tube that creates equal atmospheric pressure on both ends. We will then evaluate and compare the obtained data from both experimental and the math model to see how close we get or what conditions are required to get a closer answer. So let's talk about why even we care about this project. How is it important or even helpful? As research shows, siphon can do similar job as pump. It can be fast, simple, and cheap to create and operate. We can find siphon used in irrigation, medical, and even in our house. To do the comparison, we first begin building a math model that states our current situation. Our goal here it is to find the discharge. We then kept all the ideas or theories we know from our past study to see how good they were. The most important equation for this project was energy equation, following with friction factor, Reynolds number, and finding volumetric flow rate equation.
We used 3 different tubes, all having different inner diameters. We timed how long it took to fill a 500 milliliter water bottle and then converted that into meters cubed. Dividing that by the time it took to fill the water bottle gave us our flow rate. The 3 tubes were bought from a hardware store. They were found in terms of inches, and then we converted into standard international units. Our experimental flow rate was higher in the first 2 tubes, but in the last tube it was actually lower. Our average error ended up being 15.3%. So that we had several lessons that we learned after conducting this experiment. It'd be a lot easier to find elevations if we taped the siphon down and maintained it stationary. We could definitely use tubes of different lengths. Although we did use tubes of different diameters, we didn't use tubes with different lengths. We had to include minor head losses. We could use a larger bottom reservoir, which would make it easier than having to pull the siphon out each time. And we can consider the friction factor and conservation of mass a little more as the tubing gets larger and larger. The way we developed quality in our experiment was we used math model as validation to our experiment. It's easy to run this experiment because it's cheap, fast, and simple, so it's easy to do in the real world. We had an extensive literature review with citations and ran several trials. Thank you for listening to our experiment. We'll see you next time.